Perfect. Good morning and good evening, everyone. I hope you are having a wonderful day. I have a very short presentation, not so short, but I have tried to keep it very simple about centrifugal pumps. It's one of the most common type of pumps that you can find in the industry. Anywhere you will go where there are any hydraulics involved, centrifugal pump is very common to be seen. So in today's presentation, our objective primarily is uh, to explain the functioning of the centrifugal pump. How does it differ from other types of pump? Identify the centrifugal pump's different components, um, principle on how it operates, different type of pump models, and finally we will conclude the presentation with some of the common troubleshootings that are done for the centrifugal pump related issues. Centrifugal pump essentially is a very robust piece of pump or equipment that is used in the industry and any type of industry, whether it's petrochemical, whether it's in oil and gas, whether it's in food and beverage, everywhere you will see the centrifugal pump. It's in fact so common that you can actually find in some of the houses as well for lifting water or for pumping water from storage to a overhead tank. So it's very common to see these kind of pumps around us. Essentially, the guiding principle of the centrifugal pump is that the centrifugal pump has a part which is called an impeller. It's just a big fan, if I have to call it in a very simplistic terms, a fan which is rotating inside the body of the pump. We call it the energy to the fluid to set it in motion. Uh, the fluid will enter at the eye of the centrifugal pump. It will hit the impeller. The impeller will impart energy, and then that energy is converted into centrifugal force. That force is the one that pushes the fluid through this uh, outlet or discharge port over here. So by doing so, by imparting motion to the fluid, by giving it a centrifugal force, it creates a pressure differential or a vacuum on the eye of the centrifugal pump. When the pressure differential is created, it sucks more fluid into the eye, and then you have that cycle being repeated continuously. So one of the things about the centrifugal pumps is that the faster you will rotate them, the higher your flow rate is going to be. Uh, very simplistic. Your flow rate is directly proportional to your impeller speed. And then similarly, um, one of the things about the centrifugal pumps is that they are not self-primed. And what do I mean by self-primed is that you need to have fluid at the eye of the centrifugal pump. You need to fill this body of the centrifugal pump with fluid so that it can pump. If there is no fluid at the inlet of the centrifugal pump, it may not operate. So that's why it is said that it's not a self-priming pump. I have a very short video that um, talks about whatever I have talked about in a very brief manner.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will have a conceptual overview of working of centrifugal pumps. At the heart of the system lies the impeller. It has got a series of curved vanes fitted inside shroud plates. The impeller is always immersed in water. When the impeller is made to rotate, it makes the fluid surrounding it also rotate. This imparts centrifugal force to water particles, and the water moves radially out. Since rotational mechanical energy is transferred to the fluid, at discharge sides of the impeller, both pressure and kinetic energy of water will rise. At suction side, water is getting displaced, so a negative pressure will be induced at I. Such low pressure helps in sucking fresh water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air at eye of impeller will be negligibly small to suck fresh stream of water. impeller is fitted inside a casing. So the water moving out will be collected inside it and will move in the same direction of rotation of impeller to the discharge nozzle. Here you can note one specialty of casing. It has got increasing area along the flow direction. Such increasing area will help in accommodating newly added water stream and will also help in reducing exit flow velocity. Reduction in flow velocity will result in increase in static pressure, which is required to overcome resistance of pumping system. Here you can see more details of vanes inside impeller. They are backward curved vanes with state-of-the-art eye configuration. This vane is extracted from a...
One of the things that I want to mention over here is that at the discharge of the centrifugal pump, as it shows in the video, the pressure increases. The reason for that is the Bernoulli principle, because as the area of your casing increases over here, your velocity will decrease. And when your velocity will decrease, if people can remember the Bernoulli principle, pressure is inversely proportional to the velocity. So if your velocity is increasing or is decreasing, your pressure will increase. So your static pressure on the discharge head will increase. And that is what you want as well. You want that pressure so that that is the main purpose of the centrifugal pump as well, to impart the pressure so that it can be used further down in the processing. So that was just a quick overview about the centrifugal pumps. If we look into the overarching view of the pumps, there are three different types of pumps. The first is the centrifugal pumps that we are discussing today. The second one are called axial pumps, which also use an impeller. But in that kind of an impeller, the flow direction of the fluid will not change. For example, in the centrifugal pump, the flow will enter in a horizontal manner, which is true for this case. It will enter in the horizontal way, and then it will discharge in a vertical manner. So your fluid direction changes 90 degrees. But in the axial pumps, the fluid direction will remain same. So there is no change in the fluid direction. And the third type of pump is called a positive displacement pumps. These are your rod pumps, your beam pumps, your diaphragm pumps, your high pressure rotating pumps. And those are a different type of pumps that are used in the industry. Now, industry have a manner of selecting which pump is suitable for different applications. Usually centrifugal pumps are required when there is low to medium pressure applications, but if we have to go for a high pressure and low flow application, then positive displacement pumps are more suitable. Let's talk a bit about the components of the centrifugal pump. In the most simplistic construction, as what we talked about, there is what we call impeller, which imparts the energy to the fluid. There is what we call item number 2, which is front weir plate, and the rear weir plate, which is item number 3. Essentially, these are just weir plates which are put in as a sacrificial components so that we can maintain a proper clearance between the impeller and the casing. Then number 1 is the volute. Volute is the body of the centrifugal pump, and this body, the cross section of this body changes as we move from the suction to discharge. And the reason is the Bernoulli principle. We want to increase the area so that we can reduce the velocity and increase the pressure. Then we have what we call the shaft of the pump, which is connected with the prime mover. The bearing of the pump will provide the support and the lubrication. Then there is a frame of the centrifugal pump. And number 8 is the stuffing box or the sealing components, which ensures that the fluid does not leak into the environment. There are 3 different type of impellers which we use in the industry. The first is called an open type of impeller. Second is semi-open, and the third one is called closed impeller. As I mentioned earlier, the impeller is there just to impart the rotating energy to the centrifugal pump so that we can transfer that energy from rotating to a static head. The open type of impellers are usually used for the low pressure, high rate applications. They are more suitable for fluids which are very dirty, has a lot of abrasives, have a lot of sand, cement. And the reason for that is that just because the tolerances are not very tight in the open impeller, they do not get affected by the erosion and the abrasives very easily. They can impart uh, energy to the fluid in both counterclockwise and clockwise manner. The second type of impeller is called a closed impeller. As the name suggests, the impeller is closed, so there are no open veins over here. It can also rotate in a counterclockwise and clockwise direction. It is used primarily for the it is used cleaning fluids which are more cleaner, fluids which do not have sand and pressure and low rate applications. The third type of impellers are called semi-open impellers. These stand somewhere between the open impellers and the closed impellers. Applications in which fluid is much more cleaner, uh, has less abrasives. They can still withstand some of the abrasives, but they cannot be used with cement or anything with a lot of sand in it. And they can also be used in a counterclockwise and clockwise manner. They are primarily used for the low rate to medium rate applications where there's not a lot of requirement for the pressure. Talking about the pump sizing is important because whenever you will go to a vendor or you will go to a manufacturer that manufactures the centrifugal pumps, they will always talk about 5x6, 4x5, 10x12, 12x14. What they actually mean is that the first digit in the sizing is actually your discharge line pressure size. So in this case, this is your 5-inch discharge. And the next number, which is 6, is your suction side, which is your eye of the pump. So just something to keep in mind whenever you go to the manufacturer and he's talking about all these 2 digits, he's just talking about the discharge size pressure and the suction size pressure. Impeller rotation. This is very important in terms of impeller rotation. You can go to a site, you can go to an industry, and they will ask you whether the pump is rotating in a clockwise manner or an anti-clockwise manner. And the key to that is that you need to see the rotation of the shaft from the prime mover side. Don't see it from the suction side. The prime mover will be on the opposite side of the suction. And from there, you can see what direction your shaft is rotating. So if the shaft is rotating on a clockwise direction, then it's a clockwise pump. And if it's rotating in an anti-clockwise direction or counterclockwise direction, then it's a CCW pump. So you have to look at from the shaft that is coming from the prime mover and not from the eye of the impeller. Volute. Volute plays a very, very important role in the design of the pump. It can actually make or break an application. And the reason for why it is said is because a volute size or a volute construction can have a bigger impact on your application. So volute is essentially the casing that surrounds the impeller. The volute directs the fluid flow from pump inlet to its outlet. The volute will convert the velocity energy into pressure and also direct the flow of the fluid. So it will ensure that the flow is actually going in a particular direction. So you can connect your piping and you can connect the rest of the pieces of your process flow. And the design of the volute will depend upon what are the maximum output flow rates and pressure that you require. It also depends upon sense of pump rotation and intended pump direction as well. The volute is so important that the volute design can actually change a clockwise pump direction into anti-clockwise. And the reason for that is that if the pump is being discharged over here, you can actually extend the size of this volute and it will discharge in a counterclockwise direction. So the volute and the frame are actually, this volute is actually made up of cast iron. And this is very important when you are selecting a pump that the volute is actually made from the cast iron. The reason for that is that if it has a welded construction or a brazed construction, in a certain operating parameters, this volute can break. So it's important that it is made from one-pieced cast iron. So another thing about the volute is that the volute construction will determine what is your discharge pressure and what would be your discharge velocities. Because what you can see over here is that you can increase the diameter of the volute discharge and you will decrease your velocity and you will increase your pressure. And you can reduce it, you can reduce the diameter of this discharge line and you can increase the pressure, you can increase the velocity and decrease the pressure. Then similarly, wear plates, these are very simplistic components that go between the impeller and the volute. Essentially, they are there to provide the clearance, the required clearance between the pump and the body or the volute. And they can be made from just a piece of cast iron with a plastic coating on it, or just a piece of stainless steel. Essentially, these are sacrificial components and they can be replaced very easily. Then shimming of the pump is very important as well. Sometimes the design and the size of the wear plate is very specific. Sometimes you want to adjust that clearance. In that case, you actually use what we call shims. Shims are there to make very fine adjustments to the clearance between the plate and the impeller. The shims are laminated, so they have a particular type of coating on it. And you can actually add or remove layer to get the exact clearance that you want between the wear plate and the impeller. What will happen is that the removing of shims will move the impeller closer to the wear plate, and adding of shims will move the impeller away from the wear plate. Shaft of the pump is also a very important component, and the reason for that is that shaft is the heart of the pump that will convert the rotational energy from the prime mover and transmit it to the impeller of the pump. So a lot of emphasis is placed on the selection of the right type of shaft. There are some other types of functions that the shaft performs as well. It not only supports the impeller, it also provides the support to the bearings. It ensures that the pump is running in a smooth manner. There is no noise, there is no vibration. And it transfers the torque from the power source to the impeller so that you can actually perform your work. There are two different types of shaft types. The first is called spline shaft. The spline shaft has these kind of small little teeth on it. And what will happen is that the male part of the shaft will integrate with the female part of the shaft over here. They are used primarily where there are very high torque applications and when you are connecting your pump with a hydraulic motor. While in case of a keyed shaft, you have seen this more commonly in the industry because this is more easy to manufacture compared to spline shaft, is that you have slightly low torque applications and your prime mover is primarily either electric motor or a power takeoff from an engine. Bearing of the pumps provide a very important function. They provide the support to the shaft. They ensure that there are no excessive vibrations because the excessive vibrations can actually damage the pump. The purpose of the bearings is to reduce the rotational friction and also to provide axial support to the axial and radial loads. They are usually, in case of the centrifugal pumps, they are kind of at the end of the pump where your prime mover integrates with the shaft. These bearings usually are, they can be either self-lubricating bearings. That means there is a grease that is packed inside the races of the bearings to provide the lubrication. Sometimes we also have grease nipples through which we can inject grease into these bearings, and that is usually part of what we call a preventive maintenance of the pump. One of the things about the troubleshooting of the pump is that whenever we see excess vibrations, usually we suspect bearings. Bearings is the first place where we will check for the excessive vibrations because the rotational force can actually damage the bearings and you may experience higher vibrations. Then the next part of the pump is what we call a stuffing box or mechanical seal. Essentially, it serves one purpose. It ensures that the liquid that the pump is pumping will not leak from the pump and the air will not go inside the pump. Because in either of the cases, either liquid leaking from the pump or air going leaking inside the pump can actually have a very detrimental effects. So it is ensured that you select the correct type of sealing, and it is reliable, it is robust, because some of these pumps are actually pumping acids, they are pumping very corrosive chemicals, so you don't want those chemicals to leak into the environment. Usually mechanical oil seals, which you see right over here, these are kind of metal to metal seals. They provide really good sealing properties, and they are primarily used where there is high pressure, where you really cannot afford to have any leakage of fluid into the environment, because they are very highly reliable. Uh, they provide a very long longevity to the pump, and they do not fail very easily. Um, the next type of sealing is called packing. Um, this is uh, this is low to medium tier uh, sealing arrangement. It is not as robust as a mechanical seal, which we saw in a previous slide. They do provide good sealing capabilities, but they are primarily used when there is a low pressure, when the fluid is not very corrosive. For example, if you are pumping just water, or if you are pumping water mixed with some harmless chemical, or if you are pumping uh, um, like any type of non-corrosive, non-acidic fluid. So in that case, we can actually use packing, because even if the fluid leaks a little bit out of the packing, it will not have a huge impact to the environment. So, so the packings can be used. They should have some particular feature that we are looking for in the packing. They should have a very low coefficient of friction, because we don't want a lot of rubbing, because the rubbing means that there is a high energy dissipation, which is energy loss. We don't want that. We don't want any abrasive effect of these packings on the shaft, because they integrate with the shaft. So we don't want any abrasive effect, and we want to prevent any excessive leakage. There are two types of packing materials which are commonly used. There are rubber oil seals, which are called also automatic seals. And then there are rope type of packings, which is just like uh, a material that is made up of very cheaply available or very commonly available compounds. And then you just pack this rope packing inside that stuffing box, and you apply enough torque so that it is sealing around the shaft. Lubrication of the centrifugal pumps is very important, because the lubrication will determine what kind of vibration levels you will experience. The most common type of lubrication is oil. Um, so we will have an enclosed lubrication system. So there will be an oil lubrication system that is part of the centrifugal pump, and it makes sure that the bearings are very well lubricated. Similarly, then there are the second type is called self-lubricating bearings, um, so that uh, you do not need any oil or any type of lubricating fluid. And the third one is the grease, uh, in which you either have pre-packed grease, or either you can actually inject grease through a grease nipple, to ensure that you have less vibrations. Your bearings are uh, are well greased, and also your stuffing box uh, has grease in it, because grease can also act like a barrier, and it can actually help the rope packing or the mechanical seal to seal as well. Now, some of the recommendations from the experts is that self-lubricating packing is suitable for any pump that is pumping clean and non-abrasive fluid. So it's not pumping a slurry, it's not pumping cement, it's not pumping anything with a lot of sand or the particles in it. Um, the pumping fluid can be allowed to leak and flow through the stuffing box to cool and lubricate the packing. That means you cannot have a very corrosive fluid for the self-lubricating packing. And one of the recommendations is that we should not run the pump without fluid, uh, because it will reduce the flow of the fluid and prevent the packing from cooling and lubricating. So self-lubricating packings, my recommendation is use it when there is the application is not very severe and you can afford a little bit of leakage. Oil lubrications is they usually have a very enclosed lubrication system to prevent any cavitation. This is I recommend it to use where there are abrasive fluids, there are corrosive fluids, you are pumping acids, you are pumping cement slurries. Because what will happen is that it will really extend your packing life, it will really extend your bearing life, because it will ensure that it is properly lubricated. One of the downsides of oil lubrication is that if there is any contamination in the oil, that contamination will go inside your packing and it can actually damage your packing within seconds. Because what will happen is that contamination will cause abrasiveness, it will hurt the packing, it will damage the packing, it will cause heat generation, which will actually shorten the packing life. Grease lubrication is usually the most simplest type of lubrication. Um, It is most commonly used in the low tier applications. Uh, Most of the common pumps which you will see will have a grease lubrication. Uh, it's very low maintenance. You don't have to take care of it a lot, but you have to ensure that you are not using it for any high tier applications. Centrifugal pump can be driven by four methods. So there are four methods that can be used as a prime mover of the centrifugal pump. You can actually use a diesel engine, you can use an electrical motor, you can take a power takeoff from a gas engine, or you can use a hydraulic motor. Now, the choice of these four methods of prime mover is very much dependent on what you have available and what your application requires. For example, if you are using this pump on on an oil and gas well, you probably do not have the liberty of having a lot of electrical power, so you would need a diesel engine. But if you are using it in, for example, in a petrochemical plant or a processing facility or in a food and beverage facility, then you have a lot of electrical power available, so you can use an electrical motor. The diesel-driven pumps are very reliable. They are used in applications where you do not require a lot of maintenance. It's kind of set it, forget it kind of application. The only maintenance you would require is from time to time do a PM plan or preventive maintenance plan on the diesel engine. They are used in usually smaller to medium pressure applications. The pump is driven by extended shaft, which is usually connected through a coupling to the engine. This could be a flexible coupling. This could be a fixed coupling, um, and uh, and it's very common to find centrifugal pumps being run by the diesel drive. Then the other most common type of prime source is an electrical motor. So your electrical motor would be right over here, and then either through a coupling or through a gear reducer, you will connect it with the centrifugal pump. Um, One of the things about that is that you can actually build some interlocks over here. That means if your motor shorts or if your motor sees overcurrent, then it can actually trip the breaker and it can actually prevent your pump from having any uh, long-lasting effects. The third type of prime mover or primary source of energy for the centrifugal pump is what we call a PTO or power takeoff. This is just a coupling that is installed between your engine of your vehicle. So your vehicle actually powers up this centrifugal pump, and it is very commonly used in either irrigation kind of activities. For example, if you are irrigating the fields, or in the oil and gas activity where we are using it for pumping cement or slurries, or if we are using it to pump the frac fluid. Um, it is very common. It's very reliable, but it has very limited applications. It is only used in certain type of uh, applications. The last but not the least type of pump that primary source of energy for the centrifugal pump is what we call a hydraulic motor. Hydraulic motor, in my experience, I have seen it more commonly used in the oil and gas industry, where the hydraulic motor can be used to drive a centrifugal pump. It is also used in other industries as well, but one of the things about the hydraulic motor is that it can provide a very high torque applications. So if you are pumping a very, very thick fluid, a very, very abrasive fluid with a very high viscosity, hydraulic drives are very, very common. They are very reliable. Um, and But one of the things about the hydraulic drive is that you would need a hydraulic motor is that you would need a hydraulic power pack um, to provide the sufficient hydraulic energy to the motor so that it can drive the pump. The system of the hydraulic drive is also fitted with the over pressure relief mechanism so that if there is any high pressure spikes, then it can actually relieve that hydraulic pressure. So one of the things which I mentioned earlier in the presentation was that the centrifugal pump, um, the performance of the centrifugal pump is affected by certain factors. These factors can be uh, controlled very easily uh, by either reducing the RPM of the pump, by either increasing it or decreasing it. So the flow that is available by the centrifugal pump is primarily controlled by the rotational speed of the impeller, gravity, and thus density of the fluid being pumped. Um, you increase your rotational speed, you get a higher flow rate. You decrease it, you get a lower flow rate. It's directly proportional. And then that means that the fluid will travel farther. Uh, and what will happen is that usually your pump discharge pressures are always given in the feet. So one thing which you will hear in the pumping industry is head of the pump. By head of the pump, they are actually effectively telling you how much lift it can provide. That means, for example, if they say that the pump has a discharge height of 40 feet, that means it can pump the fluid all the way to the 40 feet of the vertical height. Very simplistic way of explaining it. One of the examples which you see is that the pump with a discharge of head of 140 feet will lift the column of water or a cement or any fluid it is pumping to 140 feet. Usually we have pump performance charts. So it's like pressure versus feet of head. It usually comes as part of the design package of the pump. The manufacturer will tell you the pump performance curves. One of the common issues that we see in the centrifugal pumps is a phenomena which we call cavitation. Cavitation is effectively a phenomena which occurs in the pump when the pressure of the liquid that the pump is trying to pump is reduced to a value which is either equal or lower than the vapor pressure. What will happen is that if your pressure of the liquid reduces below the vapor pressure, the liquid will start evaporating. When it will start evaporating, it will create bubbles, and these bubbles will move along the fluid and they will implode on the impellers. So these bubbles will act like a small little, like I wouldn't say explosions, but they will act like a small little bursts on the impellers. And if you see a pump with this kind of a wear symptom, this is what we call cavitation. Effectively, what happens is it will completely wear off the pump, and your pump won't be able to pump anymore because it is eroding the liquid, the metal from the pump surface or the impeller surface. One of the common methods of detecting cavitation in a pump is through a growling or a rumbling sound. Um, if you hear that kind of a sound, you know that it is cavitating. Some common types of pump problems. There are two common types of pump problems. Pump is too noisy or vibrates. It either means either it is cavitating or the bearing or the bearings are worn. Either the pump is out of balance. That means it is not, the propellers are not balanced anymore. So it is creating unbalanced motion. Loosening of the bolts that are tightening it to the frame. Misaligned coupling alignment. So the coupling is the part that will integrate the pump's shaft to the prime mover shaft. If there is any misalignment, it can actually result in a lot of vibration. And then broken impeller vane is another reason of noisy or vibrating pumps. Low discharge pressure, that primarily means that there are some worn out pump components. That could actually also mean that the wear plate between the impeller and the volute has actually there is just too much clearance between it. The wear plaza have actually uh, it has actually worn out. So you actually need to replace the wear plate or impeller as well. If it has been working for quite some time, it is working in a abrasive or a very corrosive fluid that may worn away the surface of the impeller. The second reason could be the restriction in the discharge. So you need to check that the discharge is free. There is no valve that is partially in a partially open condition or a partially closed condition on the pump discharge head. And also to ensure that the pump is actually rotating at a particular speed. If you are finding low discharge pressure, crank up the speed of your pump and see if your pressure will change. Uh, and yeah, that's the last one is too much clearance between the impeller and the wear plates. Then pump not priming, as I mentioned earlier at the start of the presentation, a centrifugal pump is not a self-priming pump. So you have to ensure that you have the fluid at the eye of the pump before you actually start the pump. So you have to ensure that there is water in the suction line. Then similarly, another reason the pump will not prime is that if there is too much clearance between the impeller and the front wear plate, in that case, there is like a loop that goes, so the fluid rather than going through the pump will start going between the clearances between the wear plate and the impeller and the volute. And another reason for pump not priming is the pump speed is too slow or there is restriction or a blockage in the suction. So if you are having issues with the discharge pressure, then you need to see the discharge port. And if you are having issues with pump not getting primed, you have to see if there is any blockage or any restrictions on the suction. And any loose or worn parts, especially impellers, wear plates, and volutes, will result in a not so well primed pump. And then similarly, if the impeller is loose on the shaft of the grease broken, it can also result in non-priming of the pump. So with that, I would like to conclude the presentation. And if you have any questions, let's try to answer them.
Quite awesome. Thank you very much, Professor Syed Hassaan. You have delivered a presentation that is really very, very high quality, something that's really the high class of post-secondary education, like at Atlantic International University. On behalf of the institution, I thank you very, very much for delivering this phenomenal presentation. Ladies and gentlemen, I hope you are of the same point of view. We learn significantly about the highly efficient centrifugal pumps. We learn about all the components, the bearings, the mechanical oil seats, the packing, lubrication. One very important advice we heard from Professor Syed Hassaan is that we shouldn't run the pump, the centrifugal pump, without proper lubrication. And of course, taking into account that grease lubrication is the simplest and the most practical form of the process, talking about the process of lubrication. I am very, very, very pleased, even though I am personally not in the field of mechanical engineering, but I do interact sometimes with some of the devices that I have at home. And these ideas are very, very important when it comes to resolving issues with either the centrifugal pumps Professor Hassaan talked about, or with any other type of device which is intended to move fluid, let's say, from driven rotors called impellers. A lot of technical information that we can put in use or in practice at the most convenient times. Let's top comments or compliments from Dr. Valsin and move to you, ladies and gentlemen, as I'm certain you have questions about this great presentation from Professor Syed Hassaan. The first question is coming from Ismail Adebola. Ismail, I know you are always with us, and I highly commend you for that consistent attendance of yours. But let's go ahead now and have your question for Professor.
Thank you, sir. Hello?
Yes.
Yes.
Yeah, thank you, sir. Good morning, sir.
Good morning.
Good morning.
Yeah, good morning, Professor. Good morning, everyone. Yeah, my question has been mentioned in the presentation. I'm very happy, and I'm very happy for the comprehensive presentation. But let me go straight to the point, to the question. The question is this: what are the common problems and troubleshooting techniques for centrifugal pumps? Also, what factors should be considered when selecting a centrifugal pump for a specific application?
Thank you very much, Professor Hassaan.
Thank you very much. So the common problems which you see, which I have seen in the industry, based on my 14, 15 years of experience with these pumps, is the vibration. Vibration is one of the common things that we see because it is very evident very quickly. So that and the low discharge pressure, these are the two things which I will say that are the most common problems. And when the pump starts vibrating, one of the first things that we check is the worn bearings. So we want to make sure that the ball bearings or any type of bearings that are supporting the pump shaft, they are in the correct dimensional specifications, and they are not worn out, because when they will worn out, the pump will become very noisy. And then similarly for the low discharge pressure, it's primarily looking into if there is any restrictions in the suction. If the pump speed is too slow, we are looking into that. So there are very quick few troubleshooting methods that you can use to see if they will solve the problem. But usually centrifugal pumps, which I've seen, is that when it starts vibrating, is usually a bearing problem. And if it's a low discharge pressure, it's primarily something related to the worn parts, or if there is a restriction on the suction of the pump. Yeah.
Very, very clear. Thank you very much. I hope you are satisfied, Ismail, with the answer provided by Professor Hassaan. I can see your smile, which is the indication that you are happy with our response.
Just one, sorry, just one thing to add. One of the last part of your questions was, how do we select the pump for a different application? The selection of the pump is primarily based upon what type of fluid you are pumping, what is the viscosity or the specific gravity of that fluid. If it's too viscous, you may need a multi-stage pump. That means it does not have one impeller, it has 2 or 3 impellers. Because one impeller, it can only impart certain energy. But if you have multiple impellers, then you can actually use it as something in series, and it will start. You don't have to increase your pump size too much. You can actually have a pump which is more cylindrical. Then similarly, selection of the material is very important. If you are pumping an acid which is very corrosive, you would want your impeller to be made from stainless steel or anything which will be suitable for that fluid. If you use simple carbon steel impellers, the acid will wear away the impeller too fast.
All right. Thank you very much. Jima, we are making a turn for you, brother. Jima?
Good evening or good morning.
Greetings to you.
My question, the function, what is the function of a centrifugal pump or the use, the function?
Okay. Professor Sayan, the main
Yes.
function of a centrifugal pump?
So the main function of the centrifugal pump is to increase the pressure of the fluid. That's it. If you want to move fluid from one height to another height, you need something in between to help you to pump it, right? So you install a pump in between so that you can actually suck it from one side, discharge it on the other side. That is the most simplistic way of explaining why we need pumps. Sometimes we need pumps for high pressure applications. That means you have a fluid which is at atmospheric pressure, and you want to use it in a process that would require it to be pumped at 1000 psi. And in that case, you need a pumping method to pump it.
Thank you
Get
very
it to
much.
that pressure.
All right. Stelio Sambani, what is your question, please, for Professor Syed?
Hello, good afternoon, everyone. Okay.
Good afternoon, good evening, good morning.
Yeah. Okay. My question is, I would like to know a little about the suction head of the pump. Okay. This is the first question. The second question, I would like to know if
let's look at the question one at a time, please, if you don't mind. If we have time later on, we can go back to you. Let's address the questions one at a time, please. Thank you.
Yeah, please. Okay, thank you.
Perfect. Thank you. The suction of the pump. Let's go over here. So this is suction of the pump is also called eye of the pump in the industry. And the eye of the pump usually is, it's kind of aligned with the shaft center line. So your shaft center line is right over here. And your suction is essentially entrance where your fluid will enter into the volute of the body of the pump. The suction end can be flanged, it can be bolted, and this is where you will connect your piping. Your fluid will enter from the suction, and then it will go inside the eye of the impeller. The impeller will rotate, and it will push the fluid all the way from the discharge head.
Okay.
Okay. I can go for the second, teacher, please.
No, before we go, because we will come back to you if you don't mind, Stelio, as we have some other participants with their hands up. So let's address their issues, and if we have some time, we will get back to you later on. I hope you agree to cooperate with us in that perspective. Let's go ahead and have your question, please, Olufemi.
Okay, thank you very much, sir. Can you hear me?
Yes.
Okay, good morning, sir. Professor Syed Hassaan A, good morning, sir. Thank you very much for excellent lecture. My question is on selection of a pump, for a particular application. How do we know how many pumps that we shall require for a particular application? Whether one pump will be sufficient, or do we need more than one pump? And for example, if we have to carry out a water injection, if we have to inject water into a field, into an oil field, to push out the petroleum fluids. So how do we know what are the parameters that we need to consider in selecting the pumps to use, and also how many pumps is it? I mean, for us to know how many pumps to use. Thank you, sir.
Thank you very much.
Very good question, and a very comprehensive question. So in this particular application where you are using these pumps, what you are talking about in the oil field, we call it a water flood application. So in the water flood application, the selection of pump depends upon multiple factors. The first and foremost is the formation pressure. So you need to see what pressure is in the formation, what pressure you have in the well. You have to overcome that pressure. For example, if the pressure in the well is 1000 psi, you need a pump that is going to generate at least 1500 psi, so you can overcome that 1000 psi of pressure differential, right? that is first and foremost. You need a pump which is bigger than whatever your formation pressure is in the water flood applications. The second thing is that whether you need one pump or whether you need a two pump. Now that depends upon multiple factors. You can actually have a multi-stage pump for pumping in this kind of application. And usually you would need a multi-stage pump because, as I mentioned earlier, that the pressure of the pump depends upon your rotational speed and also the size of your impeller, right? You can increase your rotational speed to a certain point. You cannot go beyond that, right? For example, if your motor can deliver like 3,500 RPM, you can only go to 3,500 RPM. You won't be able to get any pressure more than that because you cannot rotate it any faster. In that case, you have to use multi-stage pump. That means you will have multiple impellers. So one impeller will discharge into the discharge head, and then it will go to the eye of the second impeller. From the second impeller, it will go to the discharge head, go to the eye of the third impeller, and so on and so forth, right? What will happen is that by putting these impeller in series, you are increasing the pressure of the fluid in a staged manner. So what will happen is that just by making it a little bit more cylindrical and by increasing the length of the pump, you will be able to get what we call a higher pressure. Now that is exactly same principle that is used in horizontal pumping systems in the oil field, where you have these ESP barrel, which is electrical submersible pump barrel with multiple impellers all stacked into each other. And the way they are stacked is that the discharge of one impeller goes to the suction of one impeller, the second impeller, and the discharge of second impeller goes to the suction of the third impeller. And that's how you will increase your pressure. For the water flood applications, you cannot use a simple one-stage pump. You have to use a multi-stage pump.
Wow, that is very, very impressive from someone who possesses the true knowledge about the topic of centrifugal pumps. But you have a question, Bokang Muki Senatsi? We are ready for your turn, brother.
Okay, good evening, everyone.
Hello.
Yes, my question is, can centrifugal pumps transport water that containing solids or various contaminants, like maybe a polluted water with mud or some solids? Thank you.
Thank you very much. Very good question. Yes, it can to a certain extent. And for that, you may use an open impeller. So the open impeller is more tolerant to contaminants, more tolerant to abrasives. It's more tolerant to pollutants, just because it doesn't have the tight tolerances as what you have in the closed impeller. So yes, it can be used for that.
Kingsley. Chukwu. Kingsley.
Good afternoon, Professor Hassaan and Dr. Vasid.
Good afternoon, Kingsley.
Okay. Please, I really enjoyed the lecture class. I'm so grateful. I have a question that is disturbing me. So I would like to know if there are cautions one has to know before he or she can make use of this pump very well.
Okay, thank you. I wouldn't say caution because these pumps are used very commonly. It's a very simple pump to maintain. It's a very simple pump to deploy. One of the cautions I would say is to ensure that you have fluid all the way to the suction of the pump. If the line to the suction of the pump is empty, the pump will not be able to pump. It will, because it's not a self-priming pump. It has to be primed. That means it has to be filled with fluid for it to start operating. So that is one caution I would say when selecting this pump.
All right. The floor is open to you, Safo Boye.
Hello.
Yes.
Thank you for the presentation.
You're
wanted to
welcome.
know, okay, I wanted to know whether the submersible pumps also needs to be greased or lubricated.
Very good question. Submersible pumps do not need to be greased or lubricated. The submersible pumps are designed in a way that their construction is in a way that they have, in some of the submersible pumping systems that I'm aware of, that I've worked with, they have something which is called a protector or a hydraulic compensating unit, which has the lubricating oil in it. So that ensures that the seals and the bearings are always coated in oil. So it is a self-contained unit in the submersible pumps. So yeah, that's why they are submersible, because you cannot maintain them as frequently as a surface pump.
Thank you very much, Professor Hassaan. We have time for a few more questions. And we are turning now to Kelvin George. What is yours, Kelvin?
Good afternoon, good morning. Many thanks for the opportunity, and it has been quite interesting to learn more on the pumps. Now, I was wondering if, because in the cars also we have got pumps, I don't know if it works the same way this one works or it works different. Thank you.
Thank you very much. In some of the cars for smaller pumps, they do use the centrifugal pump. Sometimes we use something else, which is called a diaphragm pump, which is more simplistic in construction, has much more smaller footprint, and it can deliver in that smaller footprint, just because of the flow rate that is required, it can deliver very much similar. So yeah, in some of the cars, we have centrifugal pumps, and we also have diaphragm pumps.
Okay. We're going to try to deliver on our promise to get back to Stelio Somebody, who had a second question. And we are about to give him the opportunity to ask the second question at this time. If you are around, Stelio Somebody.
Okay, good afternoon once again. My question is, this is my doubt, okay? Because when we are doing the design of, for example, water supply system, okay? When we have the water tank before the pumps, it's an obligation to do the suction box inside of the water tank? That is my question.
Okay.
Yeah.
Suction box inside the, I'm not very familiar what do you mean by suction box? Would you be able to explain a bit more about it?
Yeah, because sometimes we have water tanks before the pumps, okay? And we need to do, because we have some, what can say, it's a suction head, okay? And we need to get this depth. I don't know that is obligation to do the suction box or not. Or you are...
It may depend upon your municipal and local regulations as well. I know some of the municipalities would require a suction box. It depends upon area to area.
Okay. The very last question, Professor Syed Hassaan has been very patient with us. We have had many questions, pretty much according to the design of our live class sessions. And as we are now about to run out of time, let's create some moment for the last question. The second with Ismail Adebola.
Thank you, sir. Sir, Professor, hello, can you hear me, sir?
Yes, we can.
Okay, good. So I really want to, my question is going to, let me put it this way, is on maintenance and prevention. Yeah, during the presentation, you mentioned the cavitation. that we shouldn't allow water to enter the cultivation. Then the question is this: what maintenance practices are recommended for centrifugal pumps, which is the maintenance on the centrifugal pumps? Also, how can someone prevent cavitation in centrifugal pumps?
Okay.
Thank you very much. One of the ways you can actually prevent cavitation in the centrifugal pump is making sure that it is primed all the time. That means it's not running dry or it's not running on partial fluid conditions. That means there is fluid coming, but it's very less compared to rest of the, like, if the fluid is not there, it will be filled by air. So make sure that air is not there, because that can also result in some of the cavitation issues.